Hello students, in this video we will be seeing NEET JEE organic chemistry questions. Let's see the first question. A gaseous hydrocarbon gives upon combustion 0.72 gram of water and 3.08 gram of carbon dioxide. So the empirical formula of the hydrocarbon is here. In question they gave combustion products 0.72 gram of water and 3.08 gram of carbon dioxide. We want to find out the formula of hydrocarbon. So we know the number of moles of product in the reaction. So let us assume the empirical formula as CXHY. Here X is the number of carbon atoms. Here Y is the number of hydrogen atoms. So for a gaseous hydrocarbon, combustion reaction can be written as here the unknown hydrocarbon CXHY plus X plus Y by 4 O2 gives carbon dioxide and water molecule. So we know the number of moles, which is equal to weight divided by molecular mass of the molecule. So for number of moles of water, which is equal to, here we know the weight of the water molecule, that is 0.72 gram. The molecular mass of water molecule is 18 gram per mole. So number of moles of water molecule is 0.04. So next, number of moles of carbon dioxide, which is equal to 3.08 gram divided by the molecular mass of carbon dioxide is 44 gram per mole. So 0.07 is the number of moles of carbon dioxide. So let's take the coefficient of water and substitute it with its number of moles. So here Y by 2 is the coefficient of water molecule. So Y by 2, which is equal to, we know the number of moles of water. So 0.04 multiplied by with 100, so that we get a whole number. So Y, which is equal to 8. So next, let's take the coefficient of carbon dioxide, which is equal to the number of moles of carbon dioxide. So we get the value of X. X is equal to 0.07 multiplied with 100. So X is equal to 7. So substitute these values in CXHY, that is unknown hydrocarbon. So here the empirical formula is C7H8. So the empirical formula of the hydrocarbon is C7H8. So the correct option is option D. Move on to the next question. The order of stability of the following carbocations. So we want to find out the order for a given carbocations. So here they give 3 carbocations. First one is allyl carbocation, second one is propyl carbocation, third is benzyl carbocation. So as the question is asking about the stability of given carbocation, so we will check first which structure shows more resonating structure. we know that more number of resonating structure means more stable the cation is. Here hyperconjugation also stabilizes the carbocations, but its effect on stability is less considerable than resonating structures. So in first structure, that is allyl group, it has two resonating structures. In propyl, there is no resonance, but in this hyperconjugation is present, which forms two conjugating structures which stabilize this carbocation. Third one is benzyl carbocation. So in this structure there are 5 resonating structures are possible. So from these number of resonating structures or conjugating structures, we can predict the stability of the given compound. So stability order of given compound is first So from these number of resonating structures or conjugating structures, we can predict the stability order of given compounds. So stability order of given compound is first benzyl is the most stability, which has 5 resonating structure, and next allyl group. The least stability is propyl group. So 3, 1 and 2. So the correct order of the stability of the given carbocation is 3, 1 and 2. So the correct option is option number D. Next, move on to the third question. Arrange the following compounds in the order of decreasing acidity. So here they give 4 compounds. The 4 compounds are phenolic compounds. So here electron withdrawing substituents. So here the phenolic compounds are substituted with electron withdrawing groups and electron releasing groups. Here electron withdrawing substituents like nitro and chlorine are increases the acidity of phenol. Electron releasing groups like methyl and methoxy are decreases the acidity of phenol. So here the first phenolic compound is substituted with chlorine, which is electron withdrawing group, which increases the acidity of phenol. So next come to the second compound. Here the methyl group is substituted in the para position of hydroxy group. Here the methyl group is electron donating group, so which decreases the acidity of phenol. Next, In third compound, nitro substituent is there. Here nitro is strong electron withdrawing group which increases the acidity of phenol. So next come to the fourth compound. Here methoxy group is substituted in the para portion of hydroxy group. Here methoxy is the electron donating group which decreases the acidity of phenol. So here we will arrange all the compounds in the order of decreasing acidity. So here the higher acidity, so here the acidic property is high for nitro substituents, so that is third compound. So third has more acidic strength, and chlorine substituent phenolic compound has the next acidic strength. And next come to methyl group. So next one is second, and methoxy group, which is here methyl group is plus I effect, and methoxy has plus mesomeric effect. So least acidic strength is methoxy substituent hydroxy group. So the decreasing order of acidity is 3, 1, 2, 4. So the correct option is option number C. Next, move on to the fourth question. A solution of levo 1-chloro-1-phenyl ethane in toluene racemizes slowly in the presence of a small amount of antimony pentachloride due to the formation of. So here we want to find out the intermediate product. So here 1-chloro-1-phenyl ethane. So the structure of 1-chloro-1-phenyl ethane is ClCH, CH3. Here the phenyl group is there, which is in levo form, which undergo reaction with a small amount of antimony pentachloride in the presence of toluene. It forms a carbocation and antimony hexachloride. This is SbCl6 minus. Here carbocation is formed. Since the carbocation is a planar species, therefore it can be attacked by antimony hexachloride either from front or back side of the carbocation with equal ease. So as a result, equal mixtures of two enantiomers of 1-chloro-1-phenyl ethane undergo racemization due to the formation of carbocation intermediate. So further we get which undergo racemization, we get D and L forms of 1-chloro-1-phenyl ethane. So here the intermediate formed is carbocation. So the correct answer is option number C. On to the fifth question. In allene C3H4, the types of hybridization of the carbon atom is or are. So here allene is the name given to propdiene. The structure of propdiene is CH2 double bond C double bond CH2. We want to find out the hybridization of the carbon atom present in propyne. So here carbon which is attached with 2 hydrogens. Here 3 carbons are there. First 1, 2, 3. So here the terminal carbons, that is carbon 1 and carbon 3, are in trigonal planar geometry. Here the 2 hydrogens which are attached with first carbon and third carbon has 3 sigma bonds, that is first and third carbon has 3 sigma bonds, and so the hybridization of first and third carbon is sp2 hybridization. So next come to the second carbon, that is central carbon, which attached with 2 sigma bonds on both sides and with 2 pi bonds, that is central carbon, that is carbon number 2, which attached with 2 sigma bonds and 2 pi bonds. Here pi bonds are not formed by hybrid orbitals, so not counted for hybridization. So here the hybridization of carbon 2 is sp hybridization. So in Allin, the types of hybridization of the carbon atoms are sp2 and sp hybridization. So the correct option is option number B. Next, see the sixth question. Among the following compounds, the most acidic is. Here they gave 4 compounds. We want to find out the most acidic one. Which one is the most acidic? So the general thing about the acidic strength is how easily any given compound gives hydrogen ion. So it depends upon various factors like inductive effect, electronegativity and resonance, etc. So here first I draw the structures of the given options. First one is para-nitrophenol. So first one is phenolic group, para-nitrophenol. Next one is para-hydroxybenzoic acid. So second option is a acidic group, para-hydroxybenzoic acid. So third option is orthohydroxybenzoic acid. So here hydroxy group which is present in the ortho position, that is next to the carboxylic acid group. So fourth option is para-toluic acid. Para-toluic acid. Okay. So here we have 3 acidic compounds and 1 phenolic compounds. So here acids have greater acidic strength than the phenolic compounds. So first let's see each and every options. So here first option is para-nitrophenol. Here hydrogen ion is attached with oxygen. So it will form, when removal of hydrogen ion takes place, it forms phenoxide ion. So which will stabilize by nitro compound. So next come to the acid group. Here also hydrogen is attached with oxygen of hydroxy, but para-hydroxybenzoic acid is itself an acidic group. So here the hydrogen will releases from more acidic hydrogen, that is from carboxylic acid group. Hence it will be more acid than phenol. So because of more resonance structure due to delocalization of carboxylic acid group. So compared to phenolic group, that is compared to option A, para hydroxybenzoic acid has more acidic strength. So next come to the orthohydroxybenzoic acid. Here hydroxy group is present at the ortho position. So ortho substituted benzoic acid are always acid due to ortho effect. So here ortho effect takes place. Since carboxylic acid is itself a bulky group, and whenever any other species is present in the ortho position, then the plane distorts and resonance occur, which make molecular more acidic. So here I will show the reactions. Here hydroxy group is present in the ortho position. So here acid is also a bulky. So here removal of H plus takes place, and the structure is stabilizes with this hydroxy group. So option C is more acidic compared to A and B. So next come to the para-toluic acid here, which is the least acidic because there is no acidic H hydrogen present. No acidic hydrogen present. So compared to all the four options, orthohydroxybenzoic acid is the more shows the more acidic strength. So the correct option is option C. Next, move on to the seventh. The correct stability order of the following resonance structure is. Here they give 4 resonating structures. We want to find out the stability order of the given resonance structures. So first thing, the stability of resonance depends on 4 factors. First one is maximum covalent bonds. So more stable. So second one is negative charge on electronegative atom. So N is, that is nitrogen, is more electronegative atom than carbon atom. So third is minimum charge separation. Minimum charge separation. Fourth is neutral molecule is more stable than charged species. So let's see the first option. In first structure, which is most stable, it has, because it has more covalent bonds and negative charges on electronegative atom. So next, so first is more stable. So next come to the third option. Here the number of covalent bond is more, okay, compared to option second and fourth. So the stability of this third structure is high compared to second and fourth. So between second and fourth, second is more stable because here the negative charge is on electronegative atom and the positive charge is on electropositive atom. So compared to fourth option, the second resonance structure is more stable. So first stable resonating structure is first option. Next, third structure has more stable compared to second and fourth. So between second and fourth, second structure, resonance structure has more stable compared to fourth. So the correct stability order of the resonance structures is first, third, second and fourth. So the correct option is option number B. Next, move on to the eighth. In the following carbocation, hydrogen, methyl that is most likely to migrate to the positively charged carbon is. Here we want to find the shifting aptitude of methyl group and hydrogen. So here shifting, which is directly proportional to stability of positivity, stability of the carbocation. So one by one we check out the stability. First we take the methyl, shifting of methyl group at C4. So here methyl group at fourth carbon, which is shifted to carbon 3, we get like this: CH3, CH, OH, here CH3, H, here CH. The positive charge comes at fourth carbon and methyl group. So next one is hydrogen at C4. So shifting of hydrogen at C4. So here shifting of hydrogen, which is greater than the methyl group, because here hydrogen atom is the smaller size. So compared to methyl group, shifting of hydrogen is easy. So easily takes place. So the structure is here OH. So when shifting of hydrogen takes place at carbon 4, the carbocation is formed, that is positive charge comes at the fourth carbon. So in option C, shifting of methyl at C2. So shifting of methyl at C2. But here we see the shifting aptitude is high for hydrogen than methyl group. So we directly move on to the option number 4, shifting of hydrogen at C2. So shifting of hydrogen at C4. So when shifting takes place, we get COH, here CH, positive charge comes at the carbon 2. So shifting is like this. CH3. Here the positive charge on carbon 2 is hyperconjugated stable due to this neighboring oxygen atom. Here oxygen has lone pair of electron, so formation of octet takes place. So shifting of hydrogen at C2 will give the more stable resonating stabilized carbocation. So the correct option is hydrogen, the shifting of hydrogen at C2. So when shifting of hydrogen at C2 takes place, we get octet completed structure, that is CH3, C double bond O, here the plus charge, here OH, here CH2, CH, CH3 twice. So the correct option is hydrogen at C2. So let's move on to the 9th question. The correct order of acidity is. So here they gave 4 structures, 2 phenolic groups and 2 acidic groups. So the acidity of phenol is due to the stability of phenoxide ion. When the electron withdrawing group is present on the phenol, the acidic character increases and the electron donating group decreases the acidity of phenolic group. So comparing of carboxylic acid and phenolic group, carboxylic acid has more acidic than phenolic group. So here we can see the first option. First option is phenolic group. First option is phenolic group, which is less stable than acidic group. So next come to the second option. Here the chlorine is substituted in the para position. Chlorine is an electron withdrawing group, so which increases the acidic strength of the phenolic group. So the acidic strength of para substituted hydroxy group is more acidic compared to unsubstituted phenolic group. So next come to the third structure, carboxylic acid, which is itself more acidic. So option 3 is the more acidic group. So next come to the, which is a toluic benzene toluic acid. So which gets acidic less than the carboxylic acid. So the stability order of given compound is 3, 4, 2, 1. So the correct order of acidity for the given compound is 3, 4, 2, 1. So option A is the correct answer. Next, see the 10th question. Hyperconjugation involves overlap of the following orbitals. So here hyperconjugation is also called no bond resonance. Here hyperconjugation is also called as no bond resonance. Hyperconjugation involves overlap of p orbital. It is the interaction of the electron in sigma bond with an adjacent p orbital. So to give an extended molecular orbital which increases the stability of the molecule. So here alkyl groups in hyperconjugation, alkyl groups with at least one alpha hydrogen. Alkyl groups with at least one alpha hydrogen atom attached with an unsaturated carbon is able to release an electron in electromeric effect, that is delocalization. I will show you one example for this hyperconjugation. So in this unsaturated carbon atom, here CH double bond CH2, in this compound hyperconjugation takes place, that is sigma electron of this one, sigma electron of CH bond is delocalized. So these are the p orbitals. These two are the p orbitals. So the sigma electrons of CH bond is delocalized with p orbitals of pi bond. So this statement is called as hyperconjugation, that is CHH double bond CH CH2 minus here H plus. So hyperconjugation involves, in this example, the sigma bond of CH is delocalized with p orbitals of pi bond. So hyperconjugation involves overlap of sigma and p orbital. So the correct option is option B, sigma and p orbital. So next, let's see the next question. The correct stability order for the following species. So here we have 4 structures. So in first structure, lone pair of electrons. Here lone pair of electrons on oxygen stabilizes the carbocation, as well as it is a tertiary carbocation, hence which is more stable. So the correct order of stability of carbocations are tertiary alkyl, secondary alkyl, primary alkyl, at last methyl carboniamine. Methane carboniamine. So when an electron donating group, that is plus I effect present, the stability of carbocation increases. So we check all the options. So come to the first option. So here the oxygen is present, which has lone pair of electrons, which stabilizes this carbocation, and as well this first structure is a tertiary alkyl carbon, so which is more stable. So next come to the second structure, which has no electron donating group, so which has no resonance, and it is a secondary alkyl group. So come to the third structure. Here the oxygen is there, so which has lone pair of electrons, so which undergoes resonance, and it is a secondary alkyl group. Come to the fourth option. So there is no resonance takes place, and it is a primary alkyl group. So overall, so comparing all the 4 structure 1 is tertiary alkyl and it has a resonance structure. Structure 2 is a secondary alkyl group, but there is no resonating structure. So structure 3 is a secondary alkyl group and it has a resonance, and fourth structure has no resonance and it is a primary alkyl group. So overall stability order for the given compound is first, third, second and fourth. So the correct option is option number D. Let's move on to the next question. Among the following, the least stable resonance structure is. So here we want to find out the least stable resonance structure. So in first option, you can see here two positive charges present at the adjacent atoms, which elevates the energy that lowers the stability most. So and also there is a minimum charge separation. So compared to all the structure, the least stable resonance structure is option A. Let's move on to the 13th question. When benzene, sulfonic acid and para-nitrophenol are treated with sodium bicarbonate, the gases released respectively are. So we need to find out the gases released when benzene, sulfonic acid and para-nitrophenol are treated with sodium bicarbonate. So first we write down the chemical equation for both the reactions. The balanced chemical equation for the reaction of benzene, sulfonic acid with sodium bicarbonate. The reaction is benzene, sulfonic acid which reacts with sodium bicarbonate. We get a sodium benzene sulfonate plus water molecule and carbon dioxide gas. So come to the next reaction, that is the chemical reaction of para-nitrophenol which is treated with sodium bicarbonate. So the chemical equation for this is para-nitrophenol which reacts with sodium bicarbonate. We get NO2 that is plus sodium, we get a sodium nitrobenzoate plus water plus carbon dioxide. So in both reactions carbon dioxide is released. So when benzene, sulfonic acid and para-nitrophenol are treated with sodium bicarbonate, the gases released are carbon dioxide. So the correct option is option B. Let's see the next question. Which of the following is obtained when 4-methyl benzene sulfonic acid is hydrolyzed with excess of sodium acetate? Here we can see 4-methyl benzene sulfonic acid which is hydrolyzed with excess of sodium acetate. So here 4-methyl benzene sulfonic acid is a strong acid. So here sodium acetate is a strong base. So when mixing of strong base and strong acid happens, the chemical reaction is said to be as neutralization. neutralization. So a spontaneous neutralization will occur between strong acid and strong base. So the chemical reaction between 4-methyl, I write down the equation for this reaction. 4-methyl benzene sulfonic acid, which is hydrolyzed with sodium benzoate, we can get a weak base and weak acid, that is sodium methyl benzoate, benzene sulfonate. Here Na plus, in fourth position methyl group is present. This is sodium methyl, sodium 4-methyl benzene sulfonate and weak acid, that is acetic acid. So we can get weak base of sodium 4-methyl benzene sulfonate and weak acid of acetic acid. So the final product of the reaction of 4-methyl benzene sulfonic acid and sodium acetate is sodium methyl benzene sulfonate and acetic acid. The option C is the correct answer. Next, move on to the 15th. For 1-methoxy 1,3 butadiene, which of the following resonating structure is least stable? So the concept of stability of resonating structure is, first one is octet of all atoms are completed and number of covalent bonds and negative charge and more electronegative atom. So here, while seeing option A and B, the octet of all atoms have completed. So the molecule in which all atoms have complete octet is more stable than atom which have incomplete octet. So option A and B are more stable because of completed octet structure. So, and also here in option A and B, larger the number of resonating structure, larger will be the stability. So thus both the options A and B are more stable. So larger resonating structures available. So next come to the structure D. Here the electron deficiency of positive charge. Here this positive charge is duly compensated with the lone pair of adjacent oxygen atom. So here, which is not available in structure C. In structure D, here this positive charge is duly compensated with the lone pair electrons of adjacent oxygen atom, but in the option C, there is not available of this support. So comparing all the options, option C has the least stable. So option C has least stable. So option C is the correct answer. Let's move on to the next question. Arrange in order of increasing acidic strength. So in the given compound, here the carboxylic acid is has a stronger acid than ammonium ion. So hence this COOH, that is acid group, is more acidic. So next come to the ammonium ion. This Z ammonium ion is more acid than Y ammonium ion, because due to minus I effect of acid on Z position. Minus I effect of acid group on Z position. So hence overall acid strength is X, Z and Y. So correct option is option A. Thank you, students.